This conference will now be recorded.
Okay, so good morning all and welcome back to the session that is Big Data Masters program and it is focused onto the cloud. So what we have seen so far, we have gone through with introduction of big data and HDFS concepts along with the Linux command. This was the first module, and over there we have gone through with big data basics and what are the challenges in order to handle big data. Then we have moved further. What are the different solutions in order to tackle those particular challenges? And then certain solutions were there and we have gone through with those particular solutions. So in today's session what I'm going to do, I'm going to provide you the insight from the module 1. Then I will give you the insight of module 2, that is distributed processing with PySpark. And at that moment, like, the students or the learners who are new, they will be onto the same page, and we will be able to move further. So that is the agenda for today's sessions, like to feed you the content that was covered in our previous sessions. Some of the students are new, so they might feel certain challenge in order to cover the previous content. So in today's session we are going to discuss about those particular things only, and it will be like both way communication. So if you are not able to understand, if you are not able to digest the certain stuff, then you can speak, you can raise your voice. Okay, so let me open a notepad, and the title for this notepad is revision. Like, we are going to cover the topics which have been, you can say, covered in our previous sessions. Okay, so the module 1, what I want to say, that is introduction to Linux command and all. So, first of all, I want to give you the insight, like why we are going through with this particular course module. That is Big Data Masters Program. You have enrolled for this particular program, but uh, you might not have the complete insight, like why we are going with this particular course module. So, Big Data Masters Program, and that is cloud focused. Cloud focused. So, what was there? Big data. Let me talk about big data. Okay. Previously, what was there? In 2003, we are talking about a particular, like, why this particular word came, and why we are looking for the solutions and all. So in 2003, it was there, it was a problem with Google. Like, the data was increasing at a very high rate, and the solutions or the machines which they were having at that moment, those particular machines were not capable to store the data, to process the data. So big data, like, to in, say, 2003, Google published a white paper, basically published a white paper in order to how to store huge amount of data. Okay, so the main challenge, if we talk about the data, there are two main challenge, like storage and processing. Okay. Storage and processing. these are the two challenges with respect to big data. And like if we are talking about a huge amount of the data, then simple monolithic machines, what I want to say over here, the single machine or single computer, okay, that will not be able to handle huge amount of data. So at that moment, what we need to have a certain solution. With the help of that, we will be able to tackle this increased amount of data. Say my computer, my laptop is having a hard disk that is of say 1 TB, yeah, and I want to store 5 TB of the data, then will I be able to store that particular data? Definitely not, because the capacity of my machine is not uh, as per the data that I'm having. So what I need to do at that moment, I need to increase the capacity of this particular machine, but there is a limitation. For a particular machine, I can increase or I can scale up the capacity up to up to a certain limit. Let me mention over here storage. These are the two challenges. I can increase the limit of storage or processing capability up to a certain limit. Okay. So up to a certain limit, like if I'm having a and machine and I'm increasing the capacity, increasing the capacity in terms of storage plus processor. Okay. So processor, like say I'm having 2 core processor, then I'm going to increase say 4 core processor, 6 core processor, but up to a certain limit I can increase the capacity. Okay. So machine, this like if I'm going to increase the capacity of a machine, that is known as vertical scaling. Okay, vertical scaling, because I'm adding the capacity in this particular machine only. You can think in this particular way, like if we are having so many people and they want to uh, uh, get certain apartments, or they want to get houses, so how we can accommodate those particular people, like if we are having the multi storage buildings, or if we are going to create the new houses. So once we are going to like create once we are going to uh, provide the solution or provide the accommodation to those people with the help of, you can say, apartments or multi story buildings, that is nothing but the vertical scaling. Like area is same, but we are occupying or providing the accommodation to multiple people. Irrespective of this, if like we are creating new houses in order to provide the accommodation to those people, that is nothing but the horizontal scaling. So same thing is applicable over here, horizontal scaling. So inside the vertical scaling, increasing the capacity of a machine, increasing capacity of a machine. And horizontal scaling, adding more machines, more machines. So storage and processing, this was the challenge which was faced uh, around 2000 by the Google, as the data was increasing at very high speed, and they were not able to store and process that particular data. So one solution which was like given or suggested by them, this was not the exact solution, this was the white paper, and white paper is having a way how to deal a particular problem. So white paper is not having the designed solution, but over here we are just providing the idea how a problem can be tackled. So in 2003, Google has published the white paper, and that was like, how to store huge amount of data, and that was nothing but distributed storage. Distributed storage. Okay, distributed storage, and Google give a name to this particular solution, that is Google File System. Okay, Google File System, GFS. This is the same like what we are having in Windows, say NTFS, New Technology File System, FAT32 file allocation table. This is like a way in order to handle huge amount of data, distributed storage. And what exactly this solution was, this idea was, like applying instead of having one machine, we are going to leverage the benefit of multiple machines. Okay, so the problem what I was discussing, like if I'm having 5 TB of the data and machine capacity was 1 TB. Okay, so 1 TB machine will not be able to handle 5 TB data. So if I'm going to add say 10 more machine, say or 5 more machines, say adding 5 more machines, more machines, say machine 1, machine 2, machine 3, machine 4, machine 5, machine 5. Okay, so machine 5 and then machine 6, so 5 new machine has been added. Now the capacity, the cumulative capacity for these particular machine is 6 TB. Then definitely I will be able to store this particular 5 TB of the data. And this is a mechanism how to tackle a huge amount of data. And this was an idea which was published by Google in 2003, like how to handle huge amount of the data. And this is nothing but distributed storage. So we were discussing, like if we are having huge amount of the data, then there are two challenges: storage, and second one is the processing. So in 2003 they have given a solution or an idea of how to tackle huge amount of data. Okay, how, in order to store it. So distributed storage is the solution for that. Then how to handle the how to process the huge amount of data. So with respect to processing, in 2004 again they have published one more paper. Google published another white paper, and that is how to process huge amount of of data. So, and they have given a name to this particular solution, that is MapReduce. Okay, MapReduce was the technology in order to process huge amount of the data. And what that technology was saying, that instead of applying one machine in order to process a particular data, multiple machines will be applied to process huge amount of data. Say machine, if like I need to calculate sum of 1 to 100, say sum 1 to 100, calculate sum 1 to 100, sum from 1 to 100. So if I'm going to have one machine, so that particular machine will be taking too much time. Then with the help of this particular solution which was published, which was given by Google in 2004, that is nothing but the MapReduce. It was saying like allow or align multiple machines, say 1 to say 15 is processed by M1, then 16 to say 30, that will be processed by M2, In the same fashion, 31 to the 45, it will be you can say processed by machine 3. Then 46 to 60, it will be processed by machine 4. Then 61 to 75, and then say 75 to 100, 76 to 100. Okay. Okay, so in this particular way, I will be able to process the entire data which was there, and it will be definitely, you can say, definitely takes less amount of time. So the outcome which was given by these particular machine, that will be the intermediate output. Say machine 1 giving me the output 1, machine 2 has given me the output 2, and this is the output 3. In the same fashion, output 4, output 5, output 5, and output 6. Okay, this is nothing but output. Let me output 1, output 2, output 3, output 4, output 5, and output 6. So this was nothing but intermediate output. Then finally, one machine will be there, intermediate output. And all of these particular things will be given to another machine that is going to work in this particular way. 5 and output 6. Okay, and that will be final output. So over here in this particular example, what we are able to see, we are mapping the data among the different machines. So this particular phase is mapper phase. Okay, mapper phase, like we are allowing multiple machines in order to process the data, in order to process small portion of the data, and that will give me an output. So that will be the intermediate output, and this particular output will be given to another machine, say, that is acting as a reducer, or it is going to reduce this particular output. Say we are having 6 output, and it is going to reduce it into the one output, so reducer, and that particular machine is providing me the final output. So this particular you can say concept which was given as a solution by Google in 2004 was nothing but MapReduce. So at that moment, nothing was developed. In 2003 and 4, these were the idea only how to tackle the problem of huge amount of data. So one person was there which was looking for these particular white papers named duck cutting. So duck cutting was the person who was looking for these particular white papers, and these papers were based upon like how to tackle huge amount of data. So he has designed a solution named as Hadoop. Okay, Hadoop. So Hadoop is distributed computing framework, and it is, you can say, working on to the master and slave methodology and slave mm, methodology. So it is working on to the master and slave master, like which is going to align slave machines in order to perform a particular task. Okay, master is known as name node. Master is known as name node, and slave machines machines are known as data node. Okay. So master and slave approach was there, and Doug Cutting has designed the solution named as Hadoop. Okay, Hadoop, that is the distributed computing framework. Distributed computing framework. Having master and slave methodology, and master is known as name node, and slave machines are known as data node. Okay, and what was there? It is a combination of two things. Hadoop is the combination of two things, that is SDFS plus MapReduce. Okay, MapReduce. SDFS, that is nothing but Hadoop distributed file system, distributed file system, and MapReduce is nothing but the same stuff. The same name has been taken by duck cutting, which was given by Google. Okay, MapReduce, and this is nothing but distributed processing framework in Hadoop ecosystem. Okay, so that's why like this Hadoop came into the picture, and like in certain organization, Hadoop is utilized at this moment as well, because uh, they are having they are not having certain latency related, you can say, constraints, so they still working on to the Hadoop. NASA was the first organization who has utilized Hadoop, then Facebook and all. So multiple organizations are still, you can say, using Hadoop, but there were certain challenges inside the Hadoop, you can say, processing. It is providing a certain latency related constraint. So whatever we are going to process with Hadoop, that is having certain latency constraint, and because of latency constraint, there are certain other solutions have been developed, and then next solution is Spark. Hadoop is disk processing system. Hadoop is disk processing framework, and Spark is in memory compute engine, and this is 100 times faster than Hadoop. Okay, so let me start from the beginning. So big data, like data was increasing on daily basis, on day by day data was increasing. So there were two challenges which was faced by Google, and they have published certain white papers, or the idea how to tackle these particular problems, and based upon these particular, you can say, white papers, a solution was developed by duck cutting named as Hadoop, and which was like capable of processing huge amount of data. The Google has published white papers only, they were not having solution at that moment, but duck cutting has, you can say, given the solution based upon those particular papers, so we were able to process, but there were certain issues or concerns once we were using Hadoop. Then we were looking for a technology which is faster than Hadoop. Okay, so Spark then came into the picture, and Spark is in-memory compute engine, and there are several other benefits. But at this moment, try to focus like Spark is very faster than Hadoop. So if we are having certain latency related issues or latency related concerns, then we can go with Spark. And definitely, like as a data engineer or data architect, latency is our main concern. Okay, if I need to do the processing with low or less amount of time, then definitely I need to have certain solutions which are providing better speed and a better latency. So Spark is there. Then with respect to the Spark, Spark is Spark is providing four different APIs: Python, Java, Scala, and R. Okay, so Spark is having four different APIs, and the person who is having the knowledge of any of these particular language, then he or she will be able to code in Spark. Okay, so Python, that is the easiest one, and we are going through with Python. Because of that particular reason only we are going through with Python. Although, like, if some persons are having the good knowledge of Java, then they can utilize, they can leverage Java for coding perspective. If they are having knowledge of Scala or R, they can leverage the Scala or R for coding inside the Spark, and to have the benefits, to take the benefits like in memory compute engine. There are several other, you can say, optimization techniques which are given by Spark, that we are going to learn once we will going through with the Spark. But at this moment, like, why we are learning Python? Because Spark is providing one API in Python. So the person who is having the knowledge of Python, they can uh, he or she can code inside the Spark, and they can take the benefit of Spark in memory compute engine, and they can minimize the latency. That is the stuff. Now with respect to the Hadoop and all, let me walk you through with the presentation. Okay, so Hadoop, let's have a discussion or certain insight like how Hadoop is working. So we are going to see the Hadoop architecture, and then how we will be able to install it, certain Linux and SDFS command. Okay, so Hadoop, what I have mentioned, say Hadoop is nothing but, over here we are having more than one node. Okay, node means machines. Say we are having multiple machines, we are taking the benefit of multiple machines. Say I'm having four node cluster: node 1, node 2, node 3, and node 4. Okay, so four node cluster is there, and I want to store a particular file that is having the size of 510 MB. This particular file I want to store in this particular cluster. So if I'm going to store it inside this particular machine, that is fine. But like those particular machine, the remaining machine will not be able to process it. So what I'm going to do over here, I will divide this particular file in terms of blocks, and say block size is 128 MB. Default block size inside the Hadoop 2 is 128 MB. Inside Hadoop version 1, it was 64 MB. So I will divide this particular file in terms of blocks, and these particular blocks will be given to these particular nodes, so that they will be able to store. And that's why, like, I will be having distributed storage and distributed process. So this particular machine, say block 1, it will be processed by node 1, block 2 will be processed by node 2, block 3 will be processed by node 3, and block 4 will be processed by node 4. So this is nothing but a distributed storage and distributed processing framework. That is fine. And this is, you can say, with respect to the version. Older version which that was having 62 MB, 64 MB block, and the newer version Hadoop 2 is having, say, 128 MB of, you can say, blocks, 128 MB of the block size. Four node cluster, and these are the slave machine. That is fine. Now like, who is going to maintain that which block is residing on which machine? Okay, if a client is coming over here and he want to, like, process this particular file, then he will not be having information which block is placed in which machine. So who is going to tackle or who is going to have that particular information, that is the master machine or master node, that is known as name node. So master machine is maintaining the metadata. Focus it over here. Focus for the like concept metadata that will be utilized in your data journey multiple times, some metadata. And in your future organization as well, metadata management, metadata, what is the schema, these particular things will be coming to you. So try to opt these particular terminology as well. So a metadata, so master node is utilized in order to maintain the metadata, and this is quite simple. Like file 1, block 1, it is given to the node 1, data node 1. dn1, that is nothing but data node 1, node 1. Block 2, it is given to data node 2. Block 3, it is given to data node 3. And block 4, data node 4. That is perfectly fine. Master node is maintaining the metadata, but there are certain issues. Okay, and that is the same. Like if a client is coming and he will ask to the master node, like, hey master node, I want to process this particular data, and where is the actual data. Then master node is going to, you can say, share the metadata with this particular client, and then client will be directly accessing these particular blocks, and he will be able to get this particular file. He will be able to process these process and get the output. That is perfectly fine, but the main challenge, if this particular data node 1 is dead, it is, you can say, lost. It might be possible, like we are having a clustered environment, and we are having multiple machines, and it might be possible one machine is dead because of power failure, because of certain, you can say, communication issues. The master node is having not having connection with this particular machine. So what will happen in this particular case? At this moment, like the block 1, because like 510 MB was the file size, and we have divided it into the 4 blocks. And if one block is lost, then the remaining file, the remaining blocks will not be utilized, because I will not be having the complete data. So what will be done in that particular case? So there is a term that is known as replication factor. Inside the Hadoop ecosystem, inside the world of Hadoop, the replicas are maintained. Replicas are nothing but the copies of that particular file. So block 1, block 2, block 3, its copies are, you can say, maintained. Then just have a look onto this particular approach. Like I am having the copies, but is this a good approach? Is this a good approach? I'm having the replicas of block 1. Is this a good approach?
No.
Mm-hmm. Why no?
The replica should be on different nodes, not on the same node for given file.
Yes.
Yes,
It should not
definitely.
be
Yeah.
evenly.
There is no point of
Mm.
creating replicas on same node. It should be on like on
Yes,
nodes,
In this
all the
case,
nodes.
even
that's
is still lost.
yes,
Redundancy.
that is correct. Like if the data node 1 is lost, then all the blocks will be lost. Okay, so there is no, you can say, sense to have the replicas into onto the, you can say, one node. The correct approach, what it will be, like I will be having the replicas. Say data node 1 is having the replicas, block 1, block 2, block 4. Okay, it can be you just check it, and it can be of, you can say, different variation, different combination, like block 1, block 2, block 3 over here. Okay, block 4, block 1, block 2. So different variations will be there, but the main thing is that same block will not be available in that particular node. If block 1 is available over here, it will not be stored as a replica in this particular node. So this is the stuff. Like if the data node 1 is down, or the connection has been lost because of any issue, so the data which is there in this particular node, that can be recovered from the another node. Say block 1, it is available over here. block 2 it is available over here, block 4 it is available over here. So we are having you can say replicas of the blocks, and with the help of the replication factor, that is default replication factor is 3 in the world of Hadoop. So we will be able to recover the information, will be able to recover the data. Okay, that is fine, we are able to recover the data, and respectively the metadata is maintained. Now there is one issue. Let me talk first issue. Okay, so one issue is there, like if this particular data node 1 is down, then what will happen to the blocks which were given to this particular data node? So at that moment, the Hadoop is going to maintain the replication factor, and in order to maintain the replication factor, the Hadoop is going to create the replicas into the remaining nodes. Say block 1, its replica is created. So I just need to have the 3 copies. Say B1 is available over here, B1 is available over here, and B1 is available over here. So replication factor 3 is maintained. So if a particular, the main thing what I want to say over here, if a particular node is down, then it is not like I'm going to compromise with the replication factor. No, the replication factor will be maintained, and it is the Hadoop, you can say, duty or the name node duty in order to maintain the replication factor. So the master node is going to create the replicas into the remaining machines so that I can have replication factor equal to 3. Now a particular data node is down, how this particular master is getting the information? So over here, at every 30 second, at every 30 second, every 3 seconds, sorry, at every 3 second, this data node is going to send an heartbeat message to the master node, hey master node, and saying that, hey master node, I'm inside the cluster only. Okay, so at every 3 second, these particular, all of the machines are going to send the heartbeat message. Okay, but if a particular machine is down, a particular node is down, and the master node is not able to get the heartbeat message consecutively for 3 cycles, that is for 30 seconds. If it is not getting the heartbeat message for 30 seconds, then it is assumed that this particular machine is not inside the cluster. At that moment, this replicas, you can say formations, will come into the picture, and the master node is going to create the replicas into the remaining machine in order to maintain the replication factor. Okay, so another issue, we were
So,
okay
what
with
are the maximum number of replicas we can put on a particular data node?
default is 3, and then depends on you, you can have 5 replication factor, 10 replication factor. There is no limit, upper, there is no limit. But if we are going to increase the replicas, then we are, you can say, consuming the resources. Okay, we are
But
consuming
what
the
if,
resources.
but take an example, what if the means take an example, if the data node should have means 20 replicas, so it would affect its means processing time also.
Yes, 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 like definitely, what will happen, once you need to search, once the client need to get that information, just look over here, so once the client is going to take the information from the master node, hey master node, I want to search this, I want to get this particular file. Now the file, for this particular file, say you have maintained 20 replicas into 20 different nodes. So at that moment, master node need to work a little bit more, like which you can say replicas uh, need to be provided, so at that moment, like the location and those particular aspects will come into the picture. So master node will try to provide the location of those particular nodes which are near to the client node. At that moment, a little bit, you can say, calculation will calculation amount will be added, and that will be, you can say, add-on stuff, add-on in terms of latency onto the processing time, right? So which block the master node, which metadata the master node need to share to the client in order to access those particular blocks, because those particular blocks are available into all of the machines, right? But it is not like that the master node is going to share the entire laundry list. So he just providing an information that block 1 can be taken from this particular node, block 2 can be taken from this particular node, right? Are you able to visualize, Anurag?
Right, right.
Okay, so just let me first walk you through this particular concept. Okay, so over here, the replicas pipeline, replica pipeline. So, what is, you can say, mentioned over here? Say data, what we are having, the data nodes. So, data nodes are nothing but different servers that we are having. Okay, so data node, these are different data nodes are placed inside the rack, and inside these particular data nodes I'm going to store my blocks. Okay, so say data node 1 is having block 1, data node 2 is having this particular rack 2, this particular data node is having block 2, this particular data node is having block 3. Okay, so I'm having the replicas, or I'm having the data among these particular nodes. Say block 1 is available over here, block 1 is available over here, block 1 is available also here, and block 1 is also available over here. Say I'm having, say, 5 replication factor 5 is there, block 1, block 2, block 3, block 4, and block 5. So which rack address will be shared by master node to the client? Rack 1, rack 2, rack 3, rack 4, or rack, say, 5. And these racks are, you can see, it might be possible these particular racks are geographically apart, like one rack is in, say, London, another rack is in Australia, third rack is in, say, uh, Mumbai, fourth rack is in, say, Bangalore. It might be possible. So how the name node is going to get this particular information based upon the latency, distance? So certain calculation will happen over there. That is the Hadoop, you can say, duty. From the data architect perspective, we are not having a concern, but like based upon the ping and all, uh, that particular latency, that the block 1, say rack 1 is nearer to the client, so that particular rack data node will be given, and the client will be able to access that particular block from this particular location, right? Right, Anurag? Is it fine? Any issues so far, guys? Anything that you are not able to digest?
No, sir, it's okay.
Okay. Okay. So what we have discussed, like data node, data node. If a data node is failing, then what will happen in that particular case? So replicas, replication factor will be maintained, and that will not be reduced. These are the, you can say, certain properties which we are going to set inside the Hadoop configurations. Okay, moving further, like if the master node is failing, what will happen in that particular case if a particular master node is failing? So if a particular master node is failing, then we are having another, you can say, okay, let me first explain this particular way. Okay, if the master node is failing, then definitely the master node is utilized in order to maintain what? Node is maintaining what, friends?
Metadata.
Metadata. So if the master node is failing, then definitely metadata will be lost. And if the metadata is lost, then it is something what, like if we know we are having, say we want to deliver a package, but we are not having the address of that particular location. Okay, so that is, you can say, the serious concern if the metadata is lost. Okay, now if the metadata is lost, then we will not be able to, you can say, access the data from the data node. Then at that moment, what is there inside the Hadoop ecosystem? We are having a secondary name node. So secondary name node is another, you can say, standby machine which is there, which is acting, which is working with master node. And this is name node that will be active one, and the secondary name node that will be the passive. This is, you can say, working in a standby mode. If this particular node is down, then it is going to take the responsibility as a master node, and then it is going to respond, it is going to, you can say, provide the services to the entire cluster. But how this secondary name node is going to take the responsibility of master node? So that is based upon two files. We are having two files as fs image and edit log. So based upon these two particular files, this secondary name node is going to take the responsibility. Just have a look onto this particular diagram. So this is primary node and this is secondary node, and we are having edit log and fs image. These are the two particular files. So edit log and fs image, these particular files will be, you can say, copied inside the secondary name node as well. It is going to have these particular files. Then over here it is going to merge these two particular file and create a new file, that is fs image ckpt, fs image checkpointing. And this fs image checkpointing is given to a shared location which is accessible to both primary name node and secondary name node. So it is going to place this fs image ckpt and replace the previous fs image file with fs image ckpt. Okay, so the file will be updated, and over here this edit log file, this will be directly, you can say, copied inside the shared memory. So with the help of these two files, if this master node is down, if the name node is down, then the secondary name node is going to take these particular files from the shared memory and it is going to perform the operation. So what exactly is there in these particular file, edit log and fs image? So just try to take an example. Say we are watching the cricket match. I'm going to quote this particular example in each and every session. So previously, like who the those who have attended the previous session, so they might be having the idea. So edit log file and fs image, these are having the status information. Okay, what exactly is going inside the cluster? Okay, or say metadata related information, and certain tasks are being performed inside the cluster, so that information is maintained in these two particular files. So in order to give you an idea, say a cricket match is going on between, say, India and, say, Pakistan, and uh, say say Dhoni and Virat Kohli is playing. So they both are onto the crease and they are playing. So let me open the notepad. FS image, FS image and edit log. Edit log plus FS image. So I was quoting the example of cricket match and Virat and Dhoni was playing and say it's time for Virat and he is batting at the moment. So like the score is say 160 for 2. Okay, the onto the scoreboard, the India score is 160 for 2 and Virat is playing and he hit say 2 fours. Okay, so 2 fours, so 160 for 2, that is the content of this edit log. Okay, at that moment once the file is captured, so the content is maintained inside the edit log. So this is nothing but the scoreboard image. So like what has been happened till yet, so that is the content inside the edit log file. Now Virat hit two consecutive four, so the scoreboard it will be, you can say, 168 for 2. But like this is the content of like two consecutive four, that is the content of FS image. Okay, 160 plus then two fours, the score what it will be, like 168 for 2. So that is the content of FS image CKPT. So over here the scoreboard image, that is 160 for 2, that is inside the edit log file, and two consecutive 4, that is the content of FS image. Like say once we have captured this particular file, and after, you can say, capturing this particular file, what has happened, that is, you can say, inside the FS image. So FS image CKPT, like now the score is 168 by 168 for 2, and that is, you can say, given to the shared memory. And like previous FS image was replaced by the newer one, FS image CKPT. Now it is having say the entire information, like this is what is happening inside the cluster. That is fine, but it might be possible there are certain new entries. Once this calculation was happening, it might be possible that certain new entries there, or new, you can say, scoreboard image is there. So at that, in that particular case, this particular information is captured inside edit log, and that is directly moved to the the shared memory, and it is going to replace the file which is available inside the shared memory. Now this secondary name node is having entire information, the all information what is required in order to take the as a master node. And that's like what is happening in this particular case, so secondary name node is going to take the responsibility based upon FS image and edit log file, and it is able to perform the task properly. Is there any issue? All of you, are you able to digest the content? Any confusion, friends? Just think for a minute and ask.
Sir, I have one confusion.
Mm-hmm.
Data node, the storage capacity will be fixed, right? So
For
every
data
time
node.
one node, yeah,
Mm-hmm.
there will be a fixed storage. So every time, like let's say one node got failed, the replicas will be created on other three nodes. It will take
Mm-hmm.
more space.
Mm-hmm.
Further, like the question is that first thing, how much space we should utilize from given data node so that for failure or fault tolerance, it has extra storage or extra capacity to create more replicas if it's required in case of fault. So that is first question.
Hmm.
Second is like once the data node is failed, what is the immediate task? Like, do we, because the system itself is creating the replica, do we try to create one more node or like replace the node? What is the further action?
So the thing like what is happening, let me explain it over here. So cluster capacity, yeah. Okay. The clusters are designed in such a way, say, I'm just giving you a rough idea. Like, say, I'm having 10 data sources, okay, and 10 data sources. From 10 data sources, cumulatively, say, I will be having around, say, 10 TB of data, okay, 10 TB of the data. Then for the replication perspective, say I want to maintain the replicas as well, and eraser coding is, you can say, applied onto this particular data. So these are the designing, you can design related questions. So 10 TB cross 1, so cross 1.6, okay. So say what will be having around 10.6 plus 10 plus and into say 1.6, so around 2.6 TB, 20 plus 26.6 TB data. So that this much of, you can say, storage I need to have in order to you can say store this these 10 file sources, okay. Now this particular storage, so I'm going to design onto, say, 60% of loading, so what I need to have, say I need to add certain add-ons onto this particular capacity. So like, say, if I need to have 10 TB of the data, then it is not like I'm going to design the maximum capacity of my cluster will be 10 TB only. I'm going to design it, say 60% load. So what I will have, I will be having, say at this moment, let me open the Excel now for the calculation perspective. 10 TB was the load that I was having, and roughly, say I want to maintain the three replicas. I don't take eraser coding and those particular thing in picture. So 30 TB I need to have. So this 30 TB is with respect to the data only that I'm getting. Okay. Now 30 TB. So I need to design this particular, you can say, system based upon certain, you can say, utilization. So I don't want to have the utilization greater than 60%. So 60% is the threshold that I am going to set for this particular cluster. 60% or 70%, more than 70% we are not going. Okay, so 70%, say I'm going to I'm not moving more than 70% with respect to the storage. So so 30 and then what it will be, uh, 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 so 30 plus 30 into 70%. Okay, so I need to have this much of storage in order to have 10 TB, in order to store 10 TB of the data. This is with respect to data only. Then there are certain other aspects as well, like say certain files will be that will be decided, Vandana. Like say some files will be having replication factor 3, some file will be having replication factor 2, some files will be having replication factor 1. Okay, in that particular way I'm going to design this particular, you can say, capacity. Okay, now the main idea, like I need to maintain the utilization 70% only, and if it is exceeding greater than 70%, then what I need to do, I need like say inside the world of cloud we are having scaling factor, auto scaling feature is there. Okay, so at that moment I'm going to scale up the cluster. Like if I was having 3 machines, so I am going to increase one more machine, so I will have 4 machine. At that moment this particular, you can see, utilization will be maintained, or if like auto scaling is not there, I'm running the cluster that is on premise. So at that moment I'm going to either like increase the capacity of machines, that is nothing but the vertical scaling, or I'm going to add more machines. But at that moment either I need to go for scaling, or I need to compromise with the with the utilization, max utilization, or I need to compromise with the replication factor. So those particular things are there. Like these are the design related stuff. Say if I want to maintain the utilization, then I need to add more machine, or I need to increase the capacity of particular machine. That is the first thing. Okay, if I don't do not want to compromise, if I want to compromise, then that is fine. I can like scale, without scaling up I can maintain the replication factor. Okay, but then it is, you can say, decided by the architect only, like in which approach we are moving, right? Hope I answered your query, Vandana.
Yes, sir.
Okay, so that is depending upon our thresholds which we have set. It is not like say we can do each and everything just by, you can say, maintaining the replication factor. No, ultimately it will impact the capacity which is given to the cluster, right? Either we need to compromise over here, either we need to go for scaling, or third one is third one we need to compromise with the replicas and all, right?
So, good afternoon, sir. Swati here.
Mm-hmm. Yes,
So,
yes, Swati.
on this replica issue, topic, na, I have one query. You are saying, na, few files we can set the replication factor as 2 or 1, or so,
Mm-hmm.
what number we want. So, how we can do it? Like, this is one of the interview questions which I have came across. So they
Mm-hmm.
are saying, they are straight away asking, okay, is it possible we can set the replication factor to 1 for a single file itself? Like in my
Yes, yes.
cluster, my files are stored in a Parquet format. So will
Mm-hmm.
it, how is this possible? Like I can set for a single file, I can set like the replication factor has to be 1 or 2.
Yes, so there are inside the Hadoop configurations, like if you want to want the replication factor to 1 or 2 or 3 for the entire cluster, then you need to set the configuration properties inside the configuration files. You can set it, I will show you like where you can set it. Inside the Hadoop conf it is there, like replication factor 1 2 3 you can set. Then it will be it will be, you can say, applicable for all what you are going to store inside the cluster. Then we are having customized commands as well. With the help of that we will be able to maintain the replication. Okay, so with those particular Hadoop DFS commands are there. Okay, so with the help of those particular commands, we will be able to maintain the replication factor to 1, 2, 3 based upon our, you can say, requirement. Let me show you. Okay, so we are having certain commands. With the help of that, we will be able to, you can change the replication factor of a file as well as a directory. Use below commands. Hadoop DFS, what I have mentioned. Setrap, setrap, right? Is it fine now? Swati?
Yes, is I can see
Mm-hmm.
the screen where you can just have the question. I'm not able to see the Hadoop command. Can you just highlight that one?
Just a minute. Hmm. So uh, I will share this particular presentation. So these are the commands: dynamically change the replication factor, Hadoop FS, DDFS replication equal to, you can mention 5. This is the file like uh, loan underscore stats 3c.csv, and I'm going to maintain in this particular location. So it is going to put this particular file from the local to this particular, you can see, directory like dfs.replication, right? This is, this you can try. Second, over here, like they have mentioned, this is the from the edureka, like dfs setrap. Okay, set replication, r for writing, for reading. Okay, so in this particular way you can change the replication. I'm highlighting over here. Are you able to see?
Yes, sir. Thank you,
Okay,
sir.
you can try. Yeah, you can try. We can change. And it depends upon, you can say, our requirement. Say once like probably you all of you are having the information how a particular frame is asynchronous transfer mode, that is ATM. Inside the asynchronous transfer mode, like what we are doing, we are converting the data into frames, and what we are having at that moment, like most required bits, least required bits, and like we are having certain we are dividing the data based upon its, you can say, use. Okay, so the data which is required heavily, so for that particular data replication factor we need to set high. Okay, in the same format, in the same, you can say, way, inside the Hadoop as well, like certain data that is that will be utilized in future, and that is, you can say, most sensitive data. So at that moment we need to maintain the replicas, multiple replicas for that particular data, and it might be possible like we are doing certain testing work, and at that moment logs and all, so there is no need to maintain the replicas to fill the storage. So that particular data can have less number of replications, right? So based upon the use case as well, like first thing, like at the cluster level we can set the configuration. Second, like if you don't want to move with the cluster configuration, you want to have the customized one, then you can go with uh, setting the replication based upon the file or based upon the directory, right? And Swati, one more thing, probably in one node cluster, you will not be able to take the benefit of these particular commands, because like in one node cluster, what is there? Like we have set the property to one only, so it will not override the system property what we have set, because one node cluster, inside one node cluster there is no sense to have multiple replicas are maintained in order to have different nodes, and different nodes are going to store the replicas of your data. If inside one node only you are going to maintain the replicas, then that is not making any sense, right?
Okay, sir.
Okay, so try to check it. These are the commands which are available. You will be able to do it. Mhm. So we were discussing about any doubt, anyone having any confusion? Gaurav, Anurag, Vandana, and who are new? Kishan, Naresh, Rahul, Shivam. Any confusion?
No, no, no confusion.
No, sir.
Okay, this is simple stuff. Okay, so we discussed about edit log and fs image. So with the help of these two files, I will be able to maintain the normal functionality if the name node is down, if the primary node is down, because the secondary name node is going to uh, take these particular files from the shared memory, and the normal functioning will keep on going. So that is the benefit of secondary name node. So I have discussed like how to, you can say, store the blocks in data node. Say, let me try to explain it over here. So we are having block 1, block 1, block 2, and block 3. So block 1, block 1. Okay, so we are having a particular file and it's block 1. I want to replicate it inside the cluster. Okay, so we are having data node 1, data node 2, data node 2, data node 3, data node 4, data node 5. This is rack 1. Okay, rack 1, rack 2, two, data node 3, data node 4, data node 5, rack 3, data node 1, data node 2, Okay. So I want to have replication 3. Okay. This is rack 1, this is rack 2, this is rack 3. And now I am sitting say in Delhi. Another rack is say in Mumbai, and this one is say in Bangalore. Okay. So I'm having a cluster, and the cluster is having different nodes. Over here I have maintained say data node 1 2 3 4 5 with respect to rack. But if I'm talking about the cluster, so data node 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15, in this particular way numbering will be there. But don't confuse yourself, this is the single cluster only having the 15 node. And three racks, and three racks are placed into the three geographical location. And like I'm having 15 node cluster. Now I want to I'm sitting in Delhi, and I want to store this particular, you can say, block 1, and I want to have replica 3. Then how I'm going to replicate these particular blocks inside the cluster? The first approach is, say, the first approach is first approach. And I can have say block 1 over here, block 1 in this particular, you can say, block 1 in data node 1, block 1. In the same fashion I will have block 2 over here, and block 3 over here. Sorry, block 1, block 1, first block, second replica, and third replica. This is the first approach. What is the issue in this particular approach? Let me first mention, write down the approach, all the approaches. So first approach, then sorry, this is the second approach that I'm going to type over here. Data node 2, data node 3. Inside Delhi only I'm going to maintain three replicas. Okay. Now I'm having third approach. What it is there? Approach 3. So block 1, block 1, and block 1. Okay, so I'm having three approaches. Just have a look, friends. Approach 3, second approach, and this is the first approach. Now you need to tell me which one is good and which one I need to have. I'm going to maintain three replicas, and I'm having three racks available onto the three geographical location. Now I want to store a particular file, and that is having say block 1, and I want to maintain the replication factor to 3. So how I'm going to place the block into different nodes in this particular cluster. You need to tell me, so which one approach is good and which I want to have. I'm going to maintain 3 replicas in each and every case. Block 1, block 2, block. Gaurav.
First approach.
Mm-hmm. Please speak loudly.
First approach.
First approach. Why first approach?
um,
Shivam. Shivam. Try to think and like don't hesitate. Don't think like you are going to answer. You are going to provide incorrect answer. Try to be interactive. Try to like think logically. What can be the solution and what will be the benefit of that particular solution? So Gaurav, why first approach?
block one is store in all the data nodes.
Mm-hmm. But that is like onto 3 geographical
Okay,
location.
yes. Mm.
uh, so if this particular block, if this particular rack is down, okay, it might be possible because of any reason. Nowadays flood is there in Delhi, so this particular block or this particular rack may have certain issues. I'm not able to get the data, so that is fine. Like I can get the data from this particular rack, but I need to take the data from far, you can say geographically far location. Okay, at that moment latency will be high, right? At that moment latency will be high. So that is fine. In terms of, in case of natural calamities, it will be good, because like if natural calamities is there, the entire nodes in this particular cluster will be having issue. Okay, say 1 2 3 4 5 at that moment, like say of rack 1, during the natural calamities or during the failure of rack, all of these particular nodes are down, then I will take the data from the different rack. It might be Mumbai or it might be Bangalore. Which one is nearer to me? I will take the data from that particular rack, or data node. But over here, there is an issue with this particular approach number 1. My data node 1, okay, data node 1 is, you can say, having this if the data node 1 is down, the rack is not having any issue, then also I need to go to Mumbai. I need to go to rack 2 to fetch the data. Okay, so in case of rack down, if in case the rack is down, that is fine. I can go to the rack 2. But like if data node 1 is down, then also I need to go. So that is, you can say, a little bit more effort I need to do over here. A little bit more at latency is there, so I can minimize it with this particular approach. I can place block 1 into 2 different node of rack 1, and block 2, uh, and the another, you can say, replica into the different, you can say, geographical apart rack 2. Okay, if this particular data node is down, then I can fetch it from here. If this is down, then I can fetch over here. So we are able to minimize the latency in this particular approach number 3. Okay, And if both of these down two are down, then I can go on to this particular location, rack 2, to fetch the block, the third replicas, and I will be able to serve the purpose, huh? Okay, in case this particular rack is down, entire rack is down, I can fetch data from here. Okay, now the second approach is not useful, because if the rack 1 is down, then the entire data, entire replicas of all the replicas of block 1 will be lost. Are you able to understand? Just have a look and ask if you are having any confusion. Gaurav, is it fine with you? Like, why? What is the
in
challenge with
in
first approach? Huh?
in both approach first and approach 3, if rack 1 is down, then we have to go to for another rack 2.
No, 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 no. If rack 1 is down, that is fine. We need to go to rack 2. But that is not the case that will be happening onto the daily basis. That is the rarest case, huh? If the entire rack is down. Huh?
Okay, okay.
Okay. So
Hmm.
for the rarest things, like it is not like from last 50 years, like we are facing the bar situation, flood situation in Delhi. So that is the rarest situation,
Okay.
right?
Hmm.
I'm just like giving certain examples that you can correlate. So say rack 1 is down because of the flood situation in Delhi. Hmm? But flood is not a, you can say, general thing. It will be, you can, natural calamities. Because of natural calamities related stuff, like we are maintaining the replicas onto different geographical locations, but natural calamities are not happening on daily basis, but it might be possible nodes can have the issue. Say data node 1 is down, and if data node 1 is down, then also I need to go into the rack number 2 in order to get the data. So that is not making any sense. I need to take the data from two for location, that is geographical apart location, and that is that particular data, like data movement will take time. Okay, over here we are dealing with huge amount of data, and data traveling, like inside the big data world, guys, data movement among different machines, among different, you can say, cluster. Okay, so that is the costly thing, costly in terms of latency. Like if I'm moving data among different nodes, that then shuffling is there, data shuffling, that is known as data shuffling. So that is the costly operation, and we need to think in such a way that movement will be less. So we need to minimize the costly operations. Okay, so data, this particular third approach number 3, will be the desired one. Like I'm going to keep two blocks, two replicas in one rack, and another replicas onto the another rack. That is the answer, two replicas in one rack, and another third replica onto the second rack, whatever we are having, right? Shivam, Swati, Gaurav, Anurag, Vandana, Kishan. Any confusion, guys? Anything that is going from above your head? Naresh, is it fine?
Yes, sir. Okay, fine.
Okay. Akhil,
So
Okay.
according to you, like the third approach is the best one, right?
Mm-hmm.
So is the real scenario is working like the same? Like if
Yes,
the first track is having any issue, the both data node 1 and data node 2 data will be getting lost. So only option will be Mumbai location. So
yes.
how this is feasible?
Uh, in which you can say scenario like data node 2 and data node 1 will have issue once the rack is down, na?
Mm-hmm.
And if over here as well rack is down, then I need to go into the rack number 2 to get that particular replica, right?
Hmm.
But over here, if any node any data node is down, then I'm having the feasibility I can take the data from this node number 2. If like entire rack is down, then definitely I'm going. So I'm having certain benefit over here. I'm able to minimize the data movement time.
Okay, means in the third approach, if any data node is down, then you are having an option of fetching the data from the same rack and same geo
Yes,
location.
yes,
Okay.
yes, yes, yes.
Okay, so thank you.
Okay, perfect. So this is a snapshot which I have downloaded from Google. So this is the data center from Amazon side, and these are nothing but racks, and different racks are placed. Okay, and over here, like we are able to see the data center from Facebook, and these are racks, and racks are having data nodes, secondary name node or master name node. That particular stuff is there. Okay, so this is so that particular concept is known as DR, disaster recovery. Yeah? Disaster recovery. Okay. And another is HA, high availability. Disaster recovery and high availability, these are the two things. Once I'm going to design the cluster, these particular things I need to have from the client side. Do you want to have high availability in your cluster? Do you want to have disaster recovery feature as well? Okay, disaster recovery, like I'm going to maintain the more replicas, or it might be possible, say if you are deploying the software, if you are deploying the software application in one region, say I'm working onto the cloud, then you are going to deploy that particular application onto the another region as well. Region means, say if we are talking about the AWS, so say India is one region and US is the another region. So I'm going to deploy the application in India as well, and I'm going to deploy the application onto the US region as well. And that is dependent upon certain other aspects as well. Say my the maximum customers from my, you can say, uh, my applications are say from say US, then I'm going to deploy it over there because the data movement time will be less over there. If you are able to if you have you can say visualized, then in India Amazon.in is there, and for other countries, say Amazon.com, Amazon.ca. So different, you can say, variations are there for the Amazon websites. Okay, that is like based upon certain the deployment is based upon certain geographical norms. Second thing, like to provide least latency to the sorry, to the customers as well. Say if the person who is sitting in US is not going to fetch the data from, you can say, India in order to uh, search the product onto the Amazon.com. So that is why, like, we need to have high availability and disaster recovery. And if disaster recovery is there, so it will be deployed onto the different region, because servers are placed onto a particular geographical location, and we are going to deploy into the another geography. So these particular things are there, and these particular things are going to increase the cost of the solution as well. And to add on your question, Vandana, like the applications are designed in such a way, so the utilization and the things are kept in such a way that uh, that the product cost will be maintained. It will be it will be within, it will remain within the thresholds as well, huh? It is not like, say, I just want to have disaster recovery and I'm going to deploy the application in all the available regions. That will not be the good, you can say, scenario. We need to think wisely, like where are the customers, okay, and what are the issues with that particular region. Like, say, if I'm talking about, say, Mumbai, so it might, there are chances of uh, there are high chances of flood and all. So then we need to think in that particular way, like we need to deploy apart from Mumbai, say we need to deploy it in Hyderabad or certain another location. So those particular things will need to be, you can say, kept in mind once we are going to deploy the applications, once we are planning for the hardware, or planning for the total infra cost for that particular application. So these particular things need to be kept in our mind, huh? Okay, so what I'm talking, high availability, huh? High availability is a feature, like say, if certain certain, you can say, hardware is down in my machine, in my application, then how the normal functionality will keep on going, how the customers will be going to perform the operations. So one thing that we have seen, that is the checkpointing. If name node is down, then secondary name node was there in order to take the responsibility of master node, and it was serving that particular purpose. So checkpointing is one solution. And then we are having second solution that is there inside the market as well, quorum of general managers. So over here, different nodes, that is general nodes, are taken, say general node 1, general node 2, general node 3. So these nodes are, you can say, grouped together as quorum of general manager. Okay, so over here, these particular nodes are going to utilize or going to maintain the history. Okay, previously we were having edit log file and fs image. So over here, this particular active name node is going to share this write edit log, huh? So each and everything which is done by this name node is maintained inside this general node, huh? So these are the multiple nodes which are tracking the activities which was performed by active name node, huh? Now if name node is down, this active name node is down, then secondary, this standby name node, not secondary, standby name node came into the picture, and it will take, it is like able to read this particular data from quorum of general managers. It is having all the track of activities which are being performed by this active name node. Okay, it take the responsibility, and then it will align all the data nodes in order to perform the task which are there, huh? So a little bit, you can say, variation has been done over here uh, inside the checkpointing, and checkpointing is done with the help of different nodes, that is known as quorum of general manager. And with the help of those particular nodes, these are able to track the activities, and standby node is able to read all the activities from here, and it is able to take the responsibility once the active name node is down. Over here, one switch is there, that is failover control, FC, switch failover control, and over here keeper is there, so keeper is going to maintain this failure connection. Once zookeeper is nothing but the resource manager related stuff over here. Okay, it is managing the resources. Okay, so once this particular active name node is down, then it is going to open the switch for secondary name node, and then secondary name node will be able to communicate with the entire cluster. So that is nothing but, you can say, quorum of general manager, and it is going to maintain the high availability inside the cluster. Okay, so if you are having any confusion, then you can ask. High availability, that is maintained by checkpointing and QJM, quorum of general managers. Any doubts so far, friends? Any doubt? Let me open one diagram. Hmm. So we were discussing about Hadoop, and we have seen like how the Hadoop is working. Hadoop is nothing but uh, the combination of multiple nodes uh, stacked in master and slave approach, and those are required in order to perform the operations, like distributed computing and distributed processing. Now, Hadoop is an ecosystem which is the combination of different modules to perform the different tasks. Just have a look onto this particular diagram, that is for the Hadoop ecosystem. And over here, what we are able to see, HDFS, Hadoop HDFS, that is distributed file system, Hadoop distributed file system. And what we have seen with respect to this is the storage layer. And Hadoop MapReduce, that is nothing but the processing framework. Now another concept is also there that we need to understand, that is nothing but the cluster manager. Okay, cluster manager, that is a yarn over here, Hadoop yarn, yet another resource navigator. So this particular cluster manager is going to maintain all the resources within the cluster. Okay, this is this is resource manager, in order to maintain the resources. So maintain resources in which way? Like say a particular task that a client want to perform, it will be processed by how many machines will be utilized in order to in order to perform that particular task, which where that particular task is being performed, then monitoring of that particular task until unless it is not performed, and that sharing the final outcome to the client. Those particular things are being performed with the help of cluster manager, that is Yana. So this is, you can say, Hadoop core layer, which is having Yarn, HDFS, and MapReduce. So MapReduce, that is processing. Now inside the Hadoop ecosystem, to perform different tasks, we are having different components. Say if we want to ingest the data, we are having data ingestion tools. So Scoop is there. Scoop, if you want to read the data, structured data, and you want to read the data from, you can say, database, SQL database, basically RDBMS. If you want to read the data from RDBMS, then Scoop is there. If you want to read the data, uh, or you can say stream data. Basically, say you want to read the read the logs from, you can say, a particular server that is continuously coming. If you want to get the tweets from the Twitter live tweets, so you can utilize Flume in order to read unstructured continuous data, okay, streamed data. Then like once the data is read, then it is placed inside the HDFS, that is Hadoop distributed file system, that is nothing but the storage. And now we need to process it. So processing can be done with the help of MapReduce and Spark. Spark, that we are going to learn. So Spark can be leveraged in order to process that particular data. Now once you are going to process and say you want to analyze, so analysis can be done with the help of Pig, Hive and Impala. These are the three tools. uh, with the help of these particular tools you will be able to perform analysis. Then we are having for the data exploration perspective, Cloudera Search is there, Hue is there. So these tools are providing the graphical user interface of these particular aspects. I say you want to have uh, you want to utilize the graphical user interface for Hive, then you can utilize Hue for that. So it is providing graphical user interface. Uji, that is workflow system. And say if you want to schedule certain jobs, so you will be able to schedule it with the help of Uji. Uji, Airflow, different schedulers are available inside the market. Say you want to take the report, you want to run a particular script at 9 a.m. in morning, so you can schedule it with the help of Uji. It is having a NoSQL database as well, that is HBase. Now if you want to query onto the data that is stored inside the HDFS, then you can leverage HBase. HBase is NoSQL database for the querying onto the data which is stored inside HDFS. Just have a look on this diagram and ask. So these are the diagram. These are the, you can see, components that we need to learn from the Hadoop perspective. And why I have shown, because you just need to do the installation with respect to these particular components. So in this particular presentation, okay, over here only I have mentioned the steps how to set up the Hadoop environment. So these are the certain hardware requirements that you need to have. Like computer must be having at least 8 GB of the RAM and maximum 16, and it is recommended to have 16 GB of RAM for better performance, and more than 50 GB space at the disk. Then virtualization software, VM, virtual box we are going to install. From this particular link you can install, download and install. And then you can download the Cloudera quick start VM from here, and then you can import. I'm having a particular playlist for this particular environment setup. You just go through with that particular playlist. So over here, just focus on to the setting up the Hadoop environment. So over here, mastering big data, Hadoop and Apache Spark. Over here, you will be able to see how to set up the and how to set up the Hadoop environment. So you can leverage this particular, you can say, recording, and you can you can perform the environment setup. Once you will be able to, you can say, have Hadoop in your machine, then it will look like this: VM, virtual box, and then you can start Cloudera Quick Start VM. So it will be look like this: Cloudera Quick Start VM. And inside the recording you will be able to see, friends, there will not be any issue. Hadoop installation, that is Cloudera Quick Start VM. Okay, so we are going to download VirtualBox. Inside VirtualBox, we are going to import Cloudera Quick Start VM. So VirtualBox is providing us Linux environment in order to have this Cloudera Quick Start VM. So Hadoop is a, you can say, framework that is given by Cloudera, Hortonworks, and Mapper. These particular organizations are providing us the Hadoop, and we will be able to perform the operations. There are, these are known as distribution, Hadoop distributions, distribution. So these are the organizations which are providing Hadoop. So for our learning journey, we are going to install Hadoop from Cloudera Quick Start VM, and with the help of VirtualBox, we will be able to have it. Once we are having this Cloud in our machine, then it will look like this. Once we are download and import, then it will look like this: Cloudera. So what you need to do over here, why we are going through with this particular revision, because uh, certain stuff is mandatory to move further, and some of you are the newest, so it is good to go through with those particular things which have been covered. So that's why, like, we are moving with the revision. So what we have seen for so far, like, big data is there, and in order to process big data, in order to store and process it, we are having distributed computing and distributed storage. So one solution is there, that is given by Hadoop, and Hadoop is having its own ecosystem, like master and slave approach. So we have gone through with those particular things in details, and how the replication factor is being maintained. There we have seen different components. So inside Hadoop ecosystem, different components are going to perform the different tasks. So if you are able to see whatever we have discussed, so those particular things we are able to see over here. Say Cloudera Quick Start VM, Hue is there, Hadoop user environment, Hadoop is there. Inside Hadoop, we are able to see, say, name node, secondary name node, data node, resource manager, node manager I have not covered. HBase we have seen, Impala, Spark, okay, Uzi, Cloudera Manager, Solar, I have not explained. So all of those components which was, you can say, mentioned over here in this particular, you can say, diagram, that we need to have idea, because it will be good to have the knowledge about these particular components. These are the basic building blocks, and this is the base for you. If you are having the knowledge about these particular components, then it will be good for you to deep down into the world of, you can say, data engineering. So the basic knowledge you need to have. So what we you will be able to have this Cloudera Quick Start VM. Once you are having this Cloudera Quick Start VM, then what you need to do, you need to go through with these basic commands. basic commands like say and Linux commands. So these particular commands are there in the presentation. I will be sharing these particular things. So just look over here. Eh, so these particular things, let me cover it. So once you have downloaded, say, Cloudera Quick Start VM, and uh, you want to utilize it. So Hadoop can be utilized into three different modes: standalone mode, pseudo distributed mode, and fully distributed mode. Standalone mode, like over here, we are running with the single machine only, and we are running with the single machine only, and distributed processing will not be there. Standalone node will not be, you can say, utilized for the development perspective. It is meant for testing perspective only. This is standalone mode. Distributed processing will not be there. A single machine, it is there with single machine only, and we will not be having distributed compute processing. Okay, standalone mode, testing perspective only. Then pseudo distributed mode. In this particular mode, although this is, you can say, working onto the single machine only, what we are going to have in our machine, so that is pseudo distributed mode, but it will work as a distributed mode. Okay, we will be able to uh, take the, you can say, benefit of distributed computing over here. So this is good for the learning perspective. Standalone single machine, no distributed computing. Over here, it is there onto the single machine, but distributed computing will be there, and good for learning perspective. Fully distributed mode, like multiple nodes will be there, and then that is the actual production environment. As an example, say Facebook is having almost 1000 nodes in its cluster, and they are working for day-to-day operations. Okay, so standalone, pseudo distributed, and fully distributed, these are the three modes. Then like what I have discussed, say Hadoop is having certain configuration file: core site, SDFS site, yarn site, mapred hyphen site.xml, hive site hyphen .xml, hbase site hyphen .xml. So but the configuration files where we can set the configuration properties. So hdfs-site.xml, let me show this particular file. So file system, Hadoop conf, and hdfs-site.xml. Okay, so Swati, you were asking na, like replication factor. So over here, replication factor has been set to 1. hdfs-site.xml. If you are going to, you can say, make it 2, 3, 4, depending upon you, like the replication factor will be applied for the all files within the cluster. Swati,
Yes, I've seen it.
okay.
Okay,
So SDF,
so SD. So one more thing, like for it, this will be getting impacted in the whole cluster, right? So in the same way, we are having some config files for your project execution also. So for if we
no,
want
no,
to go for
no. For
hmm.
that
No,
we are
for
having,
that we are having.
those particular commands. Like if you want to have customized, you can say, settings, then you need to move with those particular commands. It will be replicated for all the files and folders within the cluster, right? For that we need to have customized, like I want to have the replicas, 5 replicas for this folder only, for this directory only, right? So with respect to that only you need to set the property. Are you able to get it?
Yes, sir, clear.
Okay, so what I want to say, friends, like after installation of Hadoop, like say we have done the installation in this particular sudo distributed mode, then we are having certain configuration files. Although like Hadoop admin is the guy who is looking for these particular files. From the from the developer perspective or architect perspective, we are not bothered for these particular configuration. We just go to the admin, Hadoop admin, and tell him like I want to have 3 replicas for entire, you can say, cluster, for all the files. So he is going to set these particular properties. So yarn, that is resource manager, all the resources are managed by yarn. Map reduce hyphen site.xml, so map reduce related stuff like mapper and reducer related stuff. Hive, so with respect to Hive, the configurations are maintained inside the hive hyphen site.xml. HBase, that is the NoSQL database, so those particular configuration are maintained inside the HBase file, HBase hyphen site.xml. So these are the configuration file. You just have a look on these files and you will get the idea. And over here, like say this is the location etc hadoop and conf, so you will be able to get these particular files in your cluster. Moving further, like absolute path and relative path is there. So absolute path, like uh, the entire path, the complete path, is the absolute, is known as absolute path, and start with the root directory. Relative path, like if we are in a particular directory, then from that particular directory the path is relative path. And for programming perspective we need to follow the absolute path. Relative path may throw certain errors. Okay, so this is a particular diagram for relative path and absolute path. Say if I'm sitting over here, if I'm sitting over here, then this particular path admin and then the script and .emp.hql, so this is nothing but relative path. If I'm sitting over here, then this particular path starting from the root directory to say home, then emp, home emp, then scripts, then emp.hql, so that is nothing but absolute path starting from the root directory, and it is from say wherever you are from that directory only, that is nothing but the relative path. With the help of this particular diagram, probably you are able to understand the concept of relative and absolute path. Is it? Just have a look. You can take it in this way, say like you are from a particular village. So if I'm going to mention say ABC village, so that is nothing but the relative path. And if I'm mentioning say India, state, district, then block, and then this village, that is nothing but the absolute path, right? Are you able to get it? Gaurav, Vandana, Shivam, Akhil, are you able to get the difference between absolute path and relative path, friends? Say yes or no. If like there is,
Yes, sir.
Yes, yes,
you are able to get all of you.
yes, sir. Yes, sir. Yes.
Yes, sir.
Okay, okay, perfect. So then you need to go with these particular commands. I'm going to share this particular presentation. So you need to go with these particular commands. Commands are mentioned over here, and you just need to try to type and try to get the outcome. And what I what I'm suggesting, like you just prepare a word file, or prepare a word file, then write a command over there and copy and paste the output from the you can say terminal, and you can say convert it into the PDF and share it with me. That will be, you can say, act as an assignment. So try to say type, say, let me mention in this particular way, say this particular command is there, Hadoop fs. Let me try to copy it over here and say this one is the terminal from where you will be able to run the command. Okay, so this is the output. This was the command, and like this is the output. Then copy this and maintain in a Word file. Mhm. Word is not open. Okay, it is there. Okay, and paste it in this particular way. Copy, paste it. You can like do something to have the good visibility. Okay, but like this is the command, this is the output. So try to take the snapshot and paste the snapshot over here, depending upon you. So you will be having this particular file, and you can share it with me. You can keep that particular file with you as well for future perspective. Like once you are going to attend the interview, then go through with this particular file. That will be good for like for you, in order to review the entire stuff that we have done. Work in this particular way, you need to do the practice for commands that is which are mentioned over here. Linux and SDF commands are there, so try to uh, do the practice. Once you are able to do the practice, then the next stuff what it will be there for you. Let me uh, that stuff. So what I have mentioned, Hadoop is the combination of three things: SDFS, MapReduce, and YANA. SDFS, that is nothing but storage related component, and with respect to the commands and all, whatever you are going to learn, like creating files, moving files from local to SDFS, that is with respect to SDFS only. Yeah, to get the understanding about Hadoop distributed file system, how it is working. So those particular commands will give you insight for Hadoop distributed file system, for the Hadoop distributed file system, and you can refer the previous recordings as well. If you stuck somewhere in a particular command, then you can refer the previous recording, or you can ping me. I will be going to help you out. Then next stuff is Hadoop MapReduce, that is processing framework. So inside the Hadoop ecosystem, once you are going to process, then there are certain steps. Like first one is, say, input splitting. So input splitting is nothing but once a file is there, it will be splitted in terms of blocks. So splitter is going to split that particular files in terms of block, and the block size is depending upon the version of Hadoop that you are going to leverage. So Hadoop 2 is having 128 MB of block size. So file will be divided into 128 MB of block. Then record reader is nothing but like this particular mapper. Okay, so splitting, that is splitting in terms of blocks. Then mapping stage is there. This mapper is like this is, you can say, map reduce is like mapping phases there, like dividing the task among the available machines. So in this particular mapper is able to understand the stuff in key and value pair only. This is able to understand in key and value pair. So record reader is there. Record reader, what it will do, it will assign a random number on each block. So then it is going given to the mapper. What it will do, it will, you can say, uh, remove that particular random number and work on to the logic that we are going to give, and based upon our logic it is going to provide the output. Once it is going to, once it has processed, then it is going to, you can say, shuffle and sort this particular output and give it to the reducer, and reducer is going to provide me the final output. So let me try to explain it with the help of this. So Hadoop distribution, then you are going to with this Hadoop and Linux command that you need to learn. So inside the recordings as well, you will be able to see, and I'm going to share these presentation and all with you all. So next is, say, map reduce. Map reduce. So what I have tell, map reduce is the combination of two words, map and reduce. Map and reduce. Map and reduce. And this map and reduce, map is able to take input, key and value pair, key and value pair. Taking input in key and value pair, then providing output in key and value pair only, key plus value, and give it to, then shuffling, sorting, and the reducer, and it is also giving me the output of key and value pair. The main thing is that what I want to say, mapper and reducer. Mapper taking the input in key and value pair and providing the output in key and value pair. In the same fashion, reducer is taking the input in key and value pair and providing the output in key and value pair. So these are the two, you can say, main aspects once we are talking about the map reduce. Then what is the map reduce flow? Map reduce flow. Okay. So say I'm having a particular file. So file, it will be, splitter will be there. Splitter will be there. It is going to split the file in blocks. split the file in blocks. This is the job of splitter. Now it is given to record reader, and what record reader will do, it will add a random number, add a random number to this particular block. So then further it will be given to the mapper. Mapper, because mapper is able to understand the file, uh, the input in key and value pair. Let me walk you through with a, you can say, frequency count program, frequency count, or oh sorry, word frequency count, word frequency count program. So inside the word frequency count, say I'm having a particular paragraph. Hello, how are you, welcome to big data world, big data is big. Okay, big data will change the world. Okay, this is a paragraph that I'm having, and I'm having, say, four node cluster. Okay. Now what I'm going to do, first I need to split this particular, you can say, content into blocks. Say this one is, say, block 1. So this is the data, this is the file, this is there in a particular file, say file1.txt. Yeah? So this one is, say, block 1. This one is the content of block 2. This one is the content of block 3, and this one is the content of block 4. Now I'm having 4 blocks of this particular data. Now this is not having key and value pair. So file was there. This particular file splitter has divided into 4 blocks. So this is splitter. This is, you can say, splitter. Splitter has done this particular thing, splitter, and this is done by splitter. And this is the content that I was having. So I can remove blocks. So file1.txt. Okay. So first phase, file1.txt was there. Then second one is the splitter has splitted it into the blocks. Now these particular blocks will be given to the record reader. Now reader will come into the picture. Record reader. Okay, what record reader will do, it will assign a random number to each and every block. Why so? Because this mapper, this particular mapper is going to understand in key and value pair only. And this data is the plain data, it is not in key and value pair format. So what the record reader will do, it is going to add certain number, random number basically. Say key is this one, certain random numbers will be there. Okay, this is random number 1. Now it will be converted into key and value pair. Say 4 is there, in the same fashion 5 there. These are the random numbers which are generated by record reader. Okay, so reader has worked to this particular data and it has given this particular output. This is the output from record reader. Now this is in key and value pair format. Now this particular data can be given to the mapper. Mapper. So mapper, what it will do? Mapper is going to work on our logic. So say I'm going to split this particular data based upon the space and I'm going to fix one on each and every, you can say, word. So it will be look like this. How how one, just try to focus over here and ask if you are not getting anything, and say let me big data is big. Let me take this one. So it is going to map one and split the data. So why splitting? Because we need to write down the logic for splitting, and for map reduce, like you need to write down the logic in Java. But for this particular course module, Java is not mandatory. But we have like gone through with certain small codes in order to give you insight how the things are working happening in MapReduce with the help of Java program. So I'm going to share those particular files and all. With the help of, you will be able to, you can say, go through with this MapReduce concept. So mapper has given this particular output. Okay, now this particular output will be shuffle and sort, like movement of the records will happen over here. Say it is, it will be look like this. Say file was there, then splitter, then record reader, and then we are having multiple machines over here. Say M1, M2, M3, M4. Okay, so these are mapper machines. Mapper. So mapper has like given output in key and value pair. Shuffle and sorting will happen. Shuffle, sort, and then it is going to say it to the reducer, and reducer is going to provide the final output. So these are the things which are happening inside, you can say, uh, inside the map reduce flow. Just have a look. Now you will be able to understand this particular diagram. Okay, so over here, say we want to calculate the frequency of these particular words, like how many dogs, how many cats, and how many duck are there. Like we are going to calculate the animals. So this is the data is there in a file. It is given to the splitter. The splitter has splitted in blocks. These blocks are given to mapper, and mapper has like created based upon the space and map one with each and every word. Now like shuffling will happen, shuffling and sorting. So the same data is, you can say, maintained, and then reducing will come into the picture. What reducer will do, it is going to take the key and apply some onto the value. So at this moment, like we are able to calculate the frequency of each and every word which is there inside the data. This is nothing but map reduce flow. This is another example. Say file is there, then input format, then splitter, it is given to the splitter, then record reader, then it is given to mapper, then it is given to partitioner, sorting, then reducer, and we will be able to get the final output. So for these particular things, mapper, reducer, partitioner, and one more concept is there, that is combiner. So for these particular things we need to write down the code in Java in order to, that is, you can say, for understanding how the map reduce is working, because this Hadoop is written in Java, so it is there, like Java is there, and to code with for MapReduce we are going to, you can say, code in Java. But Java is not mandatory for our course module. For the learning perspective, like in order to understand the MapReduce concepts, two or three programs are there that we need to understand, and based upon that we will be able to get the information how the things are working. So you can go through with the recordings. I have gone through with these particular programs. So if you stuck somewhere, then you can ping me. So these are the things that you will be able to get over there. You need to write down the code in Eclipse ID inside your Cloudera Kickstart VM. How you will be able to do? You just refer the recording inside the Eclipse. You need to perform that particular coding. So I'm going to share those particular jar files with you. Just place those particular jar files, try to understand the logic and all, and you will be able to get the insight about these particular things. So that is one thing. Another, can say, aspect that we have covered so far. So that is map reduce functionality. And over here combiner is there, combiner, then sorting, shuffling, and before reducer we are having partitioner. These are the, this is the map reduce flow. File splitter, record reader, mappers are there, then combiner is known as mini mapper as well. So this is going flowed reducer. Okay, so the logic which is written over here, that is replicated inside the combiner as well. Then shuffling, sorting will happen. Partitioner is going to decide which key is moving to which reducer. So this is nothing but the map reduce flow. Just go through with the recordings, and this is what we have covered in map reduce. Then moving further, just have a look and ask if you are having any doubt over here. Just have a look. Vandana, Swati, Anurag, Rahul, Shivam, Gaurav, Raj Babu, these are the things, friends, that you need to cover. Like these are the things which we have covered in past, in our previous sessions. So I'm just giving you an overview, like the basic, and just by referring the recording you will be able to understand, right? So these are the things what we have covered so far. Then after this we have started Python. Python, because like Spark is providing 4 APIs. Let me give you the entire insight now about the course module. So, so big data was there, and big data was processed with the help of Hadoop. Hadoop was having certain challenges. Then we came to the Spark, and Spark is providing 4 APIs: Python, R, Scala, and Java. Okay, so you can pick any language in order to understand, in order to code in Spark, because Spark is going to overcome certain stuff or certain limitation which was there inside Hadoop. So we are, for this particular course module, we are going with the Python now. Python in order to code with Spark, because we want to process the data with low latency. Then nowadays what is happening, say these particular things, the organizations are moving with cloud. So we are going to cover the cloud related stuff as well. So Azure and AWS, with respect to the Azure and AWS, we are going to cover these particular things. So let me refer the course module over here. So this is the like second module, distributed processing with PySpark. We are going to cover Spark with Python. That is nothing but PySpark. Then this particular, you can say, Spark will be covered onto the Databricks, Azure Databricks. Like Spark will be covered onto the Azure Databricks. Is, you can say, high in demand tool in order to process the data with Spark. So Spark is having multiple variation. Say EMR, okay, enhanced map reduce, and Databricks. Spark can be onto the Kubernetes. Spark on Kubernetes. Spark on Kubernetes. Okay. Once we are going through with this PySpark, then I will provide you the insight about EMR, like what is happening once we are using AWS. Onto the AWS, we are having enhanced map reduce. That is, you can say, we will be dealing with Spark only over here. Then Databricks is, you can say, providing the Spark, you can say, services. So we will be going through with Databricks, and it will be done on Azure Cloud. And Spark on Kubernetes, how you will configure the Spark cluster on Kubernetes as well. Over here it is on Azure, over here it is on AWS, now onto the Kubernetes. Like if you are not going with the customized cloud, okay, you want to configure it with Kubernetes, then you can go with the this particular approach as well. Then Azure Data Factory, like one service from the Azure side, Data Factory, that will be covered. Then Spark streaming. So over here we will be learning with Spark batch processing. Spark is providing the streaming feature as well, like the streaming data. You can deal with the streaming data as well. So Spark streaming will be covered in this particular module. And with for the Spark streaming, Apache Kafka is required in order to handle the stream data. So Apache Kafka will be covered. Then we will be having it interview readiness, like I will be helping you out in order to prepare your resume, okay, and how to face the interview. Certain mock sessions will be there, mock interviews will be there. So that is the stuff. Then apart from these, like we will be having certain other things like Python that we are doing. I will be covering the SQL as well. So certain other features are there, say EC2 IAM roles, Athena, Glue. So other services are there which will be covered from the AWS and Azure side. We will be going through with big data project as well. So that is the stuff that we need to cover, and this is what we have covered so far. So we have covered this so far. We are going with we will go with the PySpark. That's why we are learning Python, and from the Python we have just gone through with basics only, like data type, numbers, variables, collections, and NumPy. And we tomorrow we are going to start with pandas library from Python. Once the pandas is over, tomorrow I will be trying to cover pandas, and then from next week onwards we will focus onto the Spark, dedicatedly onto the Spark. So that's what we have covered so far. You just need to capture these particular things, although like these certain stuff is required in our further learnings, but it is very important from the interview perspective. In order to understand the context or concept, these particular things are required. So try to go through with recordings on weekdays, and if you stuck somewhere, then you can me, I will help you out. So that's it for today's session, friends. If you are having any doubt, you can ask. Any doubt, any query? Let me stop recording.